How's it going, mathletes? Today we are going to graph absolute value functions, which gives us kind of our first look at what's called a transformation on a parent function. We're going to start by looking at what an absolute value function is and kind of the table of values that we're going to be using to graph any absolute value functions that we have. So let's start off with what an absolute value function is. Absolute value functions, f of x equals the absolute value of x. Obviously, absolute value will make the x value that you put inside there positive because it is giving you the distance from 0. So all of our output values are going to be positive. Okay, our input values are our x values, our domain values. You can put anything into this function. You can put negatives, you can put 0, you can put positives. So our domain is all real numbers. But because of the absolute value function, we are only going to be getting positive numbers and 0 out of the function. So the y values will be anything 0 to positive infinity. Okay, by the definition of what an absolute value function is. So this is 0 and all positive numbers, also known as non-negative numbers. For every point xy, the point negative xy is also on the graph. Because think about it, if you put an x value and its opposite value into this function, you're going to get the same y value back. If you put both 3 and negative 3 into this function, you get 3 back. So what that ends up looking like is a graph. I mean, I could take those points I just said. If we put in 3, we end up getting 3 back, which would be right there. And if we put negative 3, we get 3 back. If we put in 1, we get 1, and negative 1, we get 1. So what this ends up forming is a linear function on both sides of what's called an axis of symmetry, going right down the y-axis there. We have a line of symmetry called the axis of symmetry, and it forms a V. The right side of that V of this parent function has a slope of 1, and the left side of this function has a slope of negative 1. And we have what's called a vertex right here. 0, 0 is our vertex. Okay, a couple of good things to know. I'm going to continue on over here next to this. For every point xy, the point negative xy is also on the graph. What this tells us is that the function value at negative x is the same as the function value at x. This is the definition of what's called an even function. So I'm just going to have you right there that this is an even function because of that fact right there. And also graphically because it is symmetric over the y-axis, or in the y-axis. Okay, symmetry over the y-axis means that it is an even function. Algebraically, this means it is an even function. All right, so let's talk a little bit about what happens when we add some other values into that equation. So instead of just having the absolute value of x, which we kind of see right here, there's the absolute value of x, we're also going to have this a value here, which is going to be a vertical stretch, and we're going to have the h and k value as well. Okay, let's talk about the h and k values first. The h and k values represent what's called the vertex. Well, we talked about the vertex up here, but the nice thing about this form is that it gives us the vertex right here. Okay, so let's put that down here first. That the vertex is hk. Whatever hk is, that is our vertex. H is a horizontal shift. Obviously, horizontal means left to right. If h is negative, then we are going to be shifting to the, actually, if h is negative, that would actually make this x plus some sort of value in here, which means we're going to be shifting to the left. So if h is negative, we're going to be going to the left. If h is positive, if h is positive, we're going to be going to the right. I'm going to shift right. K is a vertical shift. Okay, K looks exactly like what it is out there. If it says +5, K is +5, where H is the opposite. If K is less than 0, we're going to shift down. And if K is positive, greater than 0, we're going to shift it up. Okay. We'll get back more to the whole H being the opposite thing when we start doing an example in a second or so. But that's our vertex. The vertex is H comma K. All right. We mentioned this before, that the slope of the parent function on the right side is 1, on the left side is -1. But if you have this A value here, it's going to change that slope. Okay. That A is a vertical stretch. A is a vertical stretch. Okay, it's not a shift, it's going to stretch it. It's going to affect all of our Y values. And what it's going to do is it's going to make the V look more narrow or wider, and it's going to affect the slope of the two lines. So we're just going to write this: the slope of the right side is A, and the slope of the left side is going to be the opposite of A. So basically we can just do a quick little picture like this. That side is A, that side is the opposite of A, and then why not put a little blurb there about the vertex being HK. Alright, so let's see how that affects some actual functions here. And at any time, obviously, if you need to, this is a video, pause it, listen to something again, rewrite something, go ahead and do that. Okay, so let's take a look at our first example here. Just so I don't have to keep scrolling up and down, I'm going to write down the function that we're dealing with right here. Alright, so as we compare this to what we see in that function right there, hopefully you see that the A value is 1, okay, because there's nothing right there, so A is 1, and that +4 is like our K value right there, so the K value is 4. So since K is 4, we know that this is going to shift up 4, and since the A value is 1, it's just going to have a slope of 1 and of -1 on either side of this function. So we're going to go up to 4. There's our vertex right there. And from that vertex, I just want to put a slope of 1 on the right side and a slope of -1 on the left side. I'll try to make it a little bit nicer. If you actually want to put some points and then connect the points, you can certainly do that. But I want you to notice something. When you know this information about a function, notice I don't even have a table of values here. It's not necessary. We're using what we know about the characteristics of this function to help us graph it. Okay, so this graph here we just did in red. I'm going to make that Y red. This next graph we'll do in blue here. This one says the absolute value of x minus 4. Well, now K is -4. This means that we're going to shift this down 4. A is still 1. So it's going to look, excuse me, it's going to look exactly like that graph right there. It's just going to be shifted down from the origin instead of up. So our graph now is going to start with -4. And then we're going to go up with a slope of 1. And you don't have to make this a huge graph. We're just trying to get a general idea of what this function looks like. I'm going to make this one look a little bit nicer here. I've got it symmetric in the y-axis. I know my lines don't look all that straight. That's just what happens on this surface. Nice little glitch. But they are straight lines. That's terrible. There. Only a little OCD. That's okay. All right, so let's take a look at our next example here. In this next one, we have an H value in each of our functions. So we have an H value there and an H value here. Now here's where you got to be careful. Unlike the last problem where we just said in this one, oh, K is 4 and in the next one k is negative 4. Now h is the opposite because the function is x minus h. So really this is like x minus negative 3 here. So that means that h is negative 3, which means we're going to shift this left 3. You're going to get used to this. This happens a lot with the functions that we deal with, where h is the opposite. Basically, you're going to be able to look at this function, immediately see that this is a plus, and go, we're going left. Okay? So you'll get there. So this one here now still has an a value of 1. Okay? And actually all these do. The a value is 1 in all these. And it's not shifted up or down. So we're just going to shift this left 3. So I'm going to put my vertex at negative 3, 0. And again, we have a slope of 1. And a slope of negative 1 on this side. Our last graph here is going to have a h value of positive 3, which means we're going to go to the right 3. No k value, and the a value is 1. So we're going to have a slope of 1. Good. So that's the effect that h and k have on the graph. If we had an a value, it would stretch it, and that's what we're going to see in our next example.